Here's a set of 3 problems. They are all dealing with section 1.6, which is solving inequalities. We're looking at single inequalities where you have one less than or greater than sign, and then we also are looking at compound inequalities. So the directions for these 3 problems are to solve, and then when you're done solving, draw a small graph or sketch. So we're going to start with the first one on the left. We want to solve this. First thing you want to do is we're going to distribute the 4/3. So we're going to take the 4/3 here and here. So we get 4/3 x minus, when you take 4/3 times 6, you get 8, plus 2, less than or equal to 5. Combine like terms. So we have 4/3 x minus 6 is less than or equal to 5. Add 6 to both sides. 4/3 x is less than or equal to 11. And finally, to get rid of the 4/3, we're going to multiply by its reciprocal, 3/4. We get x is less than or equal to 33/4. You can leave it as 33/4. It doesn't reduce. Your graph is going to be very basic. All I'm looking for on your number line is that you put the point that you're dealing with, 33/4. You put the correct type of circle. In this case, it is a closed circle because you have the or equal to here. And then we are looking at all numbers that are less than or equal to, so we want to shade or draw an arrow to the left. And that will get you full credit for the graph. For the second one, this is a compound inequality because you have more than one inequality sign. This is called an AND inequality, and they can be solved all at once. You're looking in the middle to see what you need to do. You need to add 4. What you do in the middle, you do on both the left and the right side. So you actually put a plus 4 3 places. 2 is less than 2x is less than or equal to 11. Last step is divide everything by 2 so you can get the x by itself in the middle. So you have 1 is less than x is less than or equal to 11 halves. When you're checking a compound inequality and AND inequality, what you want to look for is that both inequalities are pointing the same direction. They cannot have one pointing left and one pointing right, and they have to be pointing towards a number that is smaller. That will help you catch your mistakes. On your number line, you're going to put 1 and 11 halves. I'm not going to get picky on how far apart. You don't have to put all the numbers in between. We have an open circle at 1, a closed circle at 11 halves, and we are shading or connecting in between. That tells me that any number between 1 and 11 halves, including 11 halves, would be a solution to your inequality. The last one up here is a compound inequality. It's called an OR inequality. You'll actually see the word OR with these. These are 2 separate inequalities. They may be almost identical. They may be completely different, like this one. You solve them separately. The only thing that works together is you draw one graph. So for this place, you start by adding 7. So you have 2/3 x is less than 8. Multiply both sides by the reciprocal 3 halves. You get x is less than 12. Go over to the other inequality. I'm going to distribute the negative 1/5, so you get negative 1/5 x minus 3 is less than negative 4. Add 3 to both sides. Negative 1/5 x is less than negative 1. Multiply both sides by a negative 5. As soon as you multiply by a negative, you need to switch the inequality so it will become a greater than sign, greater than 5. This is going to be a very different case when you graph this. We have open circles at 5 and 12. Make sure the number that is smaller does get written first. This is actually kind of an unusual case. We have all the numbers that are less than 12 and all the numbers that are bigger than 5. What this means is that every number would be a solution to either the first inequality or the second inequality. So you can leave it like this. You can shade the entire number, or you can write this symbol, which we learned in class means all real numbers. Every number would make either the first one true or the second one true, or potentially maybe both true. Doesn't happen very often. Most of our OR cases are ones where the rays are going in opposite directions. But in this case, we are going opposite directions, but we actually have an overlap. So there are 3 examples of inequalities that you have to solve, and then getting comfortable drawing the graphs.